Hi there and welcome to my channel. In this video, my topic is angles of elevation and depression. I'll get into how you really draw these up, how you know the difference between the two, and we'll do a complex question, right? So this topic is really under the umbrella of trigs. It's covered in Form 4 and Form 5 and it's done in math. So please stay tuned to see what material I'm going to cover in this video, and I really hope that you understand it better at the end of it. Now, before I get into angles of elevation and depression, the first thing I want to review is types of angles. Now, this one is here says it's a corresponding angle. Corresponding angle goes like this. There's parallel line going this way and this way, two parallel lines, and then one line just crossing it. So usually we say we're looking for the F, right? So I don't know if you all seen it, but this is an F here written like this, right? So this angle here and this angle here will be equal and they are called corresponding, right? Now there's another F here. It will go this way, facing upward like this, with this angle and this angle here. So it would look like that as well, right? So that's my first one. Second one, alternate angles. Alternate angles, now, just as our corresponding, we look for the F. Alternate, we look for the Z. So there's a Z going like this. And what they tell us is that these two angles formed with alternate angles are equal. There's another Z going this way. This angle here and this angle here are equal as well, right? And all different directions you could find the Z, upside down and so. Now, co-interior. With co-interior now we look for the U. So this is a U formed here, right? So this says now they're not equal, but they said that these two angles add up to 180 degrees, right? So there's a U here, so we're looking for a U with co-interior. And there's also another one here. So the same rule applies to these two angles here, right? So once we know these, then we could move on to angles of elevation and depression. So now we move on to angles of elevation and depression. Now I've taken the liberty of drawing up a little diagram here with a tree, a bug at the top here. So there's a bug here. And this is another bug here, right? Now say for example, this bug was looking straight. He'll be looking along this pink line here, right? And say he sees this bug on top here and he wants to look at her, right? So then his line of sight will now be diagonal like this, right? So let me stick in a line. So this is his line of sight here. I'll just write it in like this. If he's looking straight at her. Now if she's looking straight ahead, she would look at this pink line here. She's looking straight ahead. So by this one now, looking straight ahead and then looking up, this angle formed here is the angle of elevation. Now, for her now, she's looking straight ahead, and if she looks down at him, right, her line of sight will now be this blue line here. This angle from here, this green angle, would now be the angle of depression. Sorry about that. Depression, right? So looking down means it's depression, looking up means it's elevation. Now that's, simple to understand because of those words, depression and elevation. Now, in this particular case, our two pink lines are parallel. So I could draw two arrows like this. And because of that rule that we just went over with alternate angles, this angle here will actually be the same as this angle here because there's a Z formed like this, right? Well, of course, not perfectly like this, but you know what I mean. The angle here and the angle here are the same. Now, I want to move on to a complex question to show you how we find different values using this terminology as well as sine rule. So this is my question for this video. A woman of height 1.4 meters is standing on top of a building 34.6 meters, views a tree some distance away. She observes that the angle of depression at the bottom of the tree is 35 degrees and the angle of depression at the top is 29. So the first thing we need to do is to draw a diagram. So now I proceed to do it. So trying to draw up the diagram now. This is what I have. The lady here is standing on top of a building. Her height is 1.4, so that's her height here. The height of the building she's on is 34.6, right? So that's this distance here, right? If she looks straight, that's along the pink line. If she observes the tree, which is lower, it's an angle of depression. So now drawing in those lines, this is the diagram I may have, right? So now what I'm saying here is that when she looks at the top of the tree, that's the green line here, they say the angle of depression is 29 degrees. That's 29 degrees is here, and if she looks at the bottom of the tree, the angle of depression is 35 degrees. So now, just drawing in some stuff here. If I draw a line like this and I draw this line like this, it's a right angle. You're seeing a kind of rectangle, and you're seeing a couple of triangles here. There's 1, 2, 3. This one forms another one, 4, and so on, right? So now I have, let me put in some values. I call here A, call here B, call here C, D, E, right? And here F, this point here, right? So now AE will be 1.4 plus 34.6, which will actually be 36 meters. That's this whole distance here, right? So now, what else do I know? I know that this line here and this line here are parallel. So there are some alternate angles formed here. There's one going this way, to this one here, to this one here. So if this whole angle here is 35, then it means here is 35 as well, right? So now, what I could do here is I could simply try to find, firstly find AD, the line AD, that's this line here, and then I'll use the triangle ACD, and I will use Sine Rule to find. What do I need to find? The distance of the woman from the top to the top of the tree to find AC, her line of sight. That's this line here, because this is what I need to find here, AC. That's what they're really asking us for. So these are the steps that I'm going to use to find. So to find AD now, let me go through here. I've used this triangle here. I'm using triangle AED, which is a right angle triangle. Here's my opposite, here's my adjacent, and here's my hypotenuse. So I want to find my hypotenuse, right? Because AD is the hypotenuse, right? Simple SOHCAHTOA, so I will say if I need to use opposite and hypotenuse, that would be sine. So sine of 35 will be opposite over hypotenuse. So sine 35 will end up being 36 over AD, right? So AD will be 36 divided by sine 35. That works out 62.76408464, right? So that's my whole value here in meters. So that's this distance here, AD, right? Now, if I were to use now the next triangle, as I have here, use triangle ACD. So triangle ACD now, that's a triangle looking like this. Sorry, let me go a little straighter here, right? Where here is 35. So then this angle here now will be 90 minus 35. So that will be 55. This angle here, guys, will be 35 minus 29, which will be 6. And this angle here will be 180 minus 55 minus 6, which will be 119, right? This angle here is 119. So if I were to use this triangle now with the sine rule, because I will have this side here is 62.76, etc. This side here is, this angle is 55, this one here is 119, and this one here is 6, right? So I have 3 angles on one side. I could use sine rule. So if I call here, here's A, C, and D, then let me draw this a little bigger so it will be less confusing. I'll take off this. So drawing it over, I get this diagram here. If here's big A, then here will be small a. Here's big C, then here's be small c. Here will be small d. So now I need to figure out what do I need to get. I need to get this height here. Sorry, this distance here, which is the green distance, which is AC. So I need to find small d, right? So small d is the value that I need to get. So do I have the 2 values for d? No, but I do have one value. I know big D. So I will definitely use d over sine d. And what 2 values do I have for what letter? For C. I have C, small c, and I have big C. So now I substitute these values here and I solve. So I would get d over sine of 55 is equal to small c, which is always tell my students to try to use the whole value, right? And only down to the end you multiply. So now the last thing I do, I will take my sine 55 here and send it over here and just multiply. So this will be 62 point etc. Sine 119 multiplied by sine 55. Plugging this into the calculator, I would get 58.78 meters, right? So that, everyone, is the length of AC, which is the calculated distance of the woman from the top of the tree measured along her line of sight. So that's this distance here, right? Okay, so that is part A. Now, of course, there are other ways of finding this. We could use other methods. We could find out this small a here and then equate it to this value on top here and use different things, but this is just one method, right? And this is the more complex method. So I hope that you will understand this. Now let me move on to part B. Now for part B, this will determine the height of the tree. So that's CD, that's this distance here I want to get. Now I actually could look at these triangles here, which are right angle triangles. This big one here, ABD. So that goes like this, right? There's a A, there's a B, and there's a D. And then there's a smaller triangle in here that cuts off at C, and it goes like this, right? See, now there's a right angle here, so these are all right angle triangles, right? Well, the big one, ABD and ABC are right angle. ACD, which is the one that we dealt with earlier, is not a right angle triangle. So now, what do we know from here? We know that this side here is 58.78. We know that this side here is 62.676484. Sorry, 62.76408, right? Meters. We know the angles here. We know this angle here is 55. I know all of this here is 35, right? We also know that this smaller angle here is 29 degrees. So I actually could look at the small triangle here. A will be on the side. A, B, C, right? This triangle here, that is, right? Where I have the 29 degrees to 58, and I could find BC. So this would be my opposite according to triangle, according to the angle 29 here. Here's my adjacent, and 58.78 would be my hypotenuse. So if I want to find BC, right, then what I could do, I could use opposite and over hypotenuse. So that'll be sine of 29 is equal to BC over AC. So that'll be sine of 29 is BC over 58.78. So therefore BC is sine 29 by 58.78, and that works out to be 28.49710948 meters. Now that's this distance here. But what do I need to find? I need to find this distance here, CD, right? So what I could do again is I could repeat this process. So I found BC. Now I could find BD and then take the two answers and minus them and get CD. So let me do it. Similarly, to get BD, I'll look at the big triangle now with the 62 here, 62 point something. This angle here is 35, and I want to find the opposite here. So again, I say sine of 35 is opposite over 62.76408. So therefore opposite, or what is that really? BD is really 62.76408 multiplied by sine 35, right? And that works out to be 36 meters. So lastly now, if I know BD is 36 and I know BC is 28.0, then CD will just simply be the difference. So CD will be BD minus BC, which would be 36 minus 28.49, etc. And that works out to be 1.5 around that meters. So that, everyone, is the height of the tree. So again, I hope that you all have understood my question and the solution. And please feel free to tune in to check out my other videos. Thanks guys for tuning in.